This is RTP. This is RTP180.
Having usually been giving talks at academic conferences, I have to say this is one of the most enthusiastic introductions I've ever received. So great to be here. Thank you for that. So we, as to quote Monty Python, now for something completely different. We are working on a piece of hardware technology called a shortwave infrared, SWIR, or SWIR, which we like to say rhymes with beer. So this is a different kind of camera sensor in that it is not your classic, what we call a silicon sensor that you would find in your pockets. You probably have 2 or maybe even 3 in your pocket right now, or that you might see in industrial inspection applications or security or surveillance. That's a very large, very mature industry. And we are doing something a little bit different, which is detecting light that is just beyond where those sensors stop detecting light. So it's in the infrared. It's not your classic infrared like you would see in Predator with the color vision. It's a little bit different in that's what you would call the long wave or the Predator wave. That was a joke. This is what's called the short wave. And so there's some pretty specialized applications, but we're finding that there's if it works for these folks who need to see in this spectral region, and by spectrum here I mean colors of light, that's not as opposed to the aforementioned carrier. So we see, so what we're finding is that the applications, they're very industrial, they're very specialized in nature. This is looking through a silicon wafer. You can see through many plastics that are otherwise opaque, and I'll show you some examples. You can detect moisture, chemical signatures, and the list, as we find out, keeps going and going. We got a call from a Korean company today saying, we want to do blood glucose monitoring optically without having to poke anybody, and we think we could use your camera for that. So that's a kind of an exciting one as a quick example. So here's some images. So this is what you would see with your eye or with your silicon camera, and this is what you would see with one of our cameras. So as I said, these plastics are semi-transparent. We're talking to people like Procter & Gamble who can do fill level monitoring on a production line. We have some food inspection applications where you can see subsurface bruising. This is essentially a moisture detection with our camera, whereas this is what it would look like with your eye. This pharmaceutical vials down here in the bottom corner, we had a customer who was very concerned they weren't able to see what level of liquid was in there, and they had an FDA problem, and so they're coming to us for these. And I like this one. This is for a Chilean nut sorting company, wanting to be able to distinguish between what's called the heart of a walnut and the shell. And you can see using our camera, there's a lot more contrast. And that's just because of the way materials respond to these colors of light is just different than in the visible region. This is a neat one with haze penetration. This is over a big inlet. This is like a rainstorm. This is what your eye or your camera would see, and you could see how the colors that we're looking at just cut right through it. So these are some neat applications, and we're building it here in RTP. At the core of our technology is an image sensor. It's like a piece of digital film, if you will, and it takes light that comes in, and we absorb these photons. And I could go on. It's about carriers and moving. Essentially, what you're trying to do is you're trying to detect light, turn it into a digital image, and send that out for people to do things with. So this is what we make here in the park. Maybe I'll jump ahead. We are one of those beneficiaries of MCNC. This is formerly an MCNC building, which is next door to the Broadband Center. We've inherited all of that equipment that came from that supercomputing group and some of the other spin-outs. And so by we, I mean the community of engineers that work in here. There's about half a dozen companies in here right now who are accessing this set of semiconductor processing tools. And it's just been, for a small company spinning out and getting started, it's just a great resource. So we can thank them for that. So what we're really excited about, however, is actually selling a product, because we want to sell hardware, which maybe isn't as cool as that once was, but we're working at it. And this is our camera. This is our first camera product. It comes in 3 resolutions, and what we have, I think, is an advantage over the other folks in that, because there are people that make cameras that do what our cameras do, but they cost a lot more money, and they have a lot fewer pixels. And as we all know, buying cameras, more pixels is a good thing. Thank you. And so I've got a few more application images I'll just sort through. This is an interesting one where you see this is like an orange, and you can see where the moisture is, you can detect it becomes dark, it becomes black. Here's one, this is a little bit noisy, but you can see this is something where we were doing chemical detection. We're able to, this is a project we worked on with the defense applications. They're trying to detect the signatures associated with IEDs, improvised explosive devices, and we're able to use our sensor combined with what's called a hyperspectral filter for doing chemical sensing. This is a neat application. We got to go to a training exercise with a local group of fire departments where they were essentially burning this building to the ground and using it as an opportunity to train their firefighters. So we went outside with one of our cameras, and you can see this is a smoke-filled room. It's just absolutely pitch black. And our camera, it cuts through the smoke. You can see a lot more detail of what's happening behind there. And the firefighters are very excited about this because they say one of the biggest challenges they have is not finding where the fire is, but trying to navigate through these black smoke-filled rooms. And so this is another kind of neat application. This was, some of my colleagues went to Pilot Mountain. They were doing some climbing there and got to the top and took an image. This is what it looks like with a regular sensor. And you could just see there's just you can see, I think we decided that this was a power plant that was many, many miles distant, and you can't even make it out in here, but because of the way light travels through the atmosphere. So it's long-range surveillance, which is something that is of interest. This is another version of this rainy, cloudy day, and the camera cutting through. We've done some drone work. This is actually a building site at RTI where they were doing some construction, and we put our camera on our drone, and we're just more for proof of principle than anything else. And with that, I thank you for your attention.